All right, so video problem 24A, we're looking at this curve and we're trying to figure some stuff out about it. All right, so first we're asked, what is the analyte? Is it a strong or weak acid or base? Well, notice how we're starting off at a high pH, right? Something around 14. So that means my analyte, which is what I start with, is a base. And notice how the pH doesn't change a lot at the very beginning. This means that it is a strong base I'm starting with. Okay? If this were a weak base, I'd see something like this. Okay? I'd see a sudden drop, and then I'd get into that buffer region, and then it decreases. With a strong base, I see no sudden drop. All right. So this is a strong base, and I'm going to add to it a strong acid. This is my analyte. So my analyte is analyte, and my titrant. So my analyte is my strong base, and my titrant is my strong acid. Right? And in fact, on the screen, it tells me that I have NaOH, that indeed is a strong base, and I have HCl as my titrant. Okay, I always say it's good to tell me something, my base and my acid, right? Make sure to differentiate those, because otherwise it gets confusing. All right, so what do I know about my NaOH? I know I have 40 mLs of it. All right, what do I know about my HCl? I know it's 2.2 molar. Okay, do I know anything else? Well, I have this curve. This curve tells me the pH as I add in titrant. Right? That's my HCl. So the equivalence point is the mLs of the titrant. All right, so I can look at the curve, and, we'd have to guesstimate or estimate based on the curve. It looks to me around 23 mLs. So I have 23 mLs. So now, if I want to figure out the concentration of my NaOH, I need to know something about my acid. Okay? Now remember, at this point, moles acid equals moles base. That's what an equivalence point is. So I can probably use these two pieces of data to figure out moles acid. It's going to be 0.023 liters times 2.2 molar. That's going to get me my moles. 0.0506 moles of my acid. Well, that means that's also how much moles of base I have at the equivalence point. All right, so I have moles, I have a liters or a volume, so I can calculate molarity based on 0.0506 moles over 0.04 liters. And that's going to get me 1.2. Let's see, I started off with 3 sig figs, so I'm going to end with 3 sig figs for my NaOH. Okay? So I use the fact that at that equivalence point, moles acid equals moles base. All right, there it is on the screen. We start off by figuring out what it is. If we don't know anything about it, i.e., what's my analyte, what's my titrant, it's hard to do anything else. Okay, and then I use that equivalence point to tell the difference. All right, now let's move on to problem 24b. In 24b, we have a different titration curve. Okay, but titration curves are always going to be pH versus ml titrant. All right, let's look at this. At the very beginning, we see something like that. Okay? So we're starting off at low pH. That means this must be, I'm having a problem with markers right now, this must be an acid. Okay? And notice what's happening. We see this sharp increase, and then it kind of levels off, where this is my buffer region. Okay, so that means that this must be a weak acid. Okay? Well, if my analyte is an acid, my titrant must be a base. And it must be a strong base because we don't use weak bases. All right, so this goes up like this. All right, so we have our equivalence point right here. And right here, that is our midpoint. Okay, so let's see what we know about my acid and my base. All right, so I have 22 mLs of my acid. I know I have 0.45 molar of my base. And that's it. Well, I do know one other thing. I do know that this equivalence point, right? That equivalence point is at 30 mLs. So 30 mLs, at 30 mLs, I have equal amounts of acid and base. Okay? So let's use that. So moles base equals 0.03 liters times 0.45 moles per liter. And that's going to get me 0.0135. All right, that's how many moles base. So that's also how many moles acid I have at that point. Okay? So now I can figure out the molarity of my acid by saying it's 0.0135 moles over 0.022 liters, and I get 0.61 molar acid. I don't know what this acid is. I'm just told that it's an acid. All right. This is a weak acid titrating with a strong base. There's one other piece of information we can get from this chart, and that is by looking at this buffer region. Okay? So notice that my equivalence point was at 30 mLs. Well, halfway to that, so 15 mLs, I'm at my midpoint. Okay? And at that midpoint, which is in the middle of the buffer region, this is the place where pH equals pKa. So here's 15. So I can look here and I can say, oh, my pH, it looks like it's pretty much exactly at 4, right? So my pKa of my acid is equal to 4. So if I want to find the Ka for my acid, it's going to be 10 to the minus pKa, or 10 to the minus 4, or 1 times 10 to the minus 4. This is my pK, or my Ka for my weak acid. Okay, here's the solution one more time. We always start off by saying what's my analyte, what's my titrant. Okay, then I use the equivalence point to find the moles of the titrant. In this case, this is of the base. I use the fact that at the equivalence point, moles acid equals moles base, and from there I can figure out concentration. I can also find, because this is a weak acid, I can find its Ka based on the fact that at this midpoint, which is right here, right, my pH equals my pKa. And then I use that to find Ka. All right, so 24C deals with indicators. So we're asked some questions about different indicators. These three: methyl orange, bromothymol blue, and O-cresylphthalene. Okay. So what is the color of bromothymol blue at pH 4? Okay. So here's bromothymol blue at 4. Seeing that this is below the color change range, it's going to be the same color as right here. So it's going to be yellow. Okay. How about O-cresylphthalene at pH 8? That's right here. So that's going to be clear because it's less than the color change region. And then methyl orange at H plus equals 1 times 10 to the minus 3. Well, I can use the fact that pH equals negative log of 1 times 10 to the negative 3. That's going to get me a pH of 3. So at pH 3, methyl orange is going to be red. All right, problem number 2, which would be a good indicator if a neutralization has an equivalence point at pH 9. Okay, so I want to have something that is going to change colors around 9. Methyl orange would be bad because around 9 it's going to be yellow the entire time. Same thing for bromothymol blue. But notice O-cresylphthalene is going to go from clear to red in this at this pH. So I'm going to look for the first indication of it turning red, and that's going to tell me, oh, I'm at the equivalence point. All right, let's do the last one. So we're asked for HCl is titrated with NaOH with bromothymol blue as the indicator. And we're asked what happens to the color change during the titration, right? What does it start off with? What does it change? Okay, so let's figure out what we're doing. We have HCl, and we're titrating it with NaOH. So that means I'm starting with HCl, and then I'm adding in NaOH. So HCl must be my analyte, and NaOH is going to be my titrant. So if I think what this pH curve is going to look like, it's going to start off at low pH. Why? Because HCl is an acid. It's a strong acid. This is a strong base. So that means I'm going to get a curve right like this, where the equivalence point is going to be at pH 7. Okay? So if I look at it for my bromothymol blue at color or at pHs below 6, it's yellow. So all during this portion, it's going to be yellow. Once it gets to around pH 7, it's going to turn green, and then it's going to turn blue, right? Once it gets to high pH. Okay? So we're going to go from yellow to green and then to blue. With the point where it's at green, that's when we're going to say, oh, we're at the equivalence point. All right, so here it is on the screen, and that'll be it for video problems number 24. Talk to you later.